So this is a little introduction to algebra, and one of the things that you can do when starting algebra is you can work with algebra tiles. And the algebra tiles are different shapes and different sizes and different colors. So the larger square represents an x squared. X is just a variable. So letters in algebra, letters are variables. Letters can represent anything, any number. So when I say x, it might be 2, it might be 3, it could be -5, it could be anything. If I use the letter y, then that's a different variable. It also represents a number. It would just be a different number than the letter x. So this square is called the x squared tile. So that would be like an x times an x. And you have two different colors because you have a positive and you have a negative. Likewise, these rectangles, they are the x tiles. Again, you have two different colors because you have a negative and a positive. Usually the way that you do it is the red is always negative, and then the other color is always positive. And then you have these single tiles that don't have letters. So things that don't have letters, those are called constants. If you think about it in English, the word constant means that it never changes. And that's kind of the same in algebra. So the number 3, if I said +3, that's never going to change. I'm always going to add 3. Whereas if I say plus x, I don't know what x is. X could be 2, and so sometimes I might be adding 2. Or maybe x is -5, and then sometimes I'm adding -5. So the letters are called variables, and the numbers without a letter, so just a number, is called a constant. Now, if I had a couple x's, for example, here, if I had 2 of these tiles, that's called 2x. And so again, the variable is x. The 2, that's another special word. That's called the coefficient. And that tells you how many x's you have. Or maybe they're y's, and then it tells you how many y's you have. If you have negative tiles, so what if I had 3 of these? And that would be -3x. Then my coefficient would be -3. Again, it's how many I have, and the sign is included. So the coefficient is the number in front of the letters or in front of the variables. When I put things together, like for example, I have 2, whoops, shoot, I'm going to undo that. Let's say I have 2 x's and 3 of these. I create an expression, and I can call that expression 2x plus 3. So together, that whole thing equals the expression 2x plus 3. If I made the expression equal to something, if I said 2x plus 3 equals 10, then it's called an equation. If I just say 2x plus 3, it's called an expression. And the interesting thing here is that's actually would be your answer. These are called terms. So for example, the 2x, this is a term, and the 3 is also a term. They are not the same. They don't both have x's, or they don't both have x squareds. They're different. So they are not like terms. They are not alike. Therefore, we can't add them. We cannot add 2x and 3 together. We could add 2x and 3x together. For example, if I had 2 x's there, and I added 3 more x's, I now have that. In total, I have 5 x's. I can add 2x plus 3x, but I cannot add 2x and 3. They are not like terms. So that's just a little bit of basic introduction and terminology. There will be more detail about the terminology and more practice with getting used to these new words. That's one of the most confusing parts about algebra, is just being introduced to some new words. What we're going to do now, though, is look at how do we put these terms together? How do we create expressions and then collect our like terms together? So for example, if it asks you to model this using algebra tiles, so 3x squared, what that's asking you to do is to take 3x squared tiles, then we're going to add 3x tiles. Then we're going to take away 4. That means minus 4. So that sign, that negative sign, goes with the 4. That means put 4 negative tiles down. Then this means negative. So when there's no number, it means negative 1x squared. So we're going to take 1x squared. Then it says take away 4 x's and add 1. That is modeling our expression. We've now written down, or we've used tiles to represent each of those terms. Each thing here, so each of these individual things, 3x squared and 3x and negative 4 and negative x squared and negative 4x and positive 1, notice how I included the sign. Those are all terms. There are 6 individual terms in that expression. So that's an expression with 6 terms. Now it asks us to simplify. What that means is it means put the things that are the same together. So put the x squareds together, put the x's together, put the numbers or constants together. So for example, what I can do is I can take my x squareds, and I can have my 3x squareds, and I can put them with my 1 negative x squared. Then I can take my 3 x's and I can put them with my 4 negative x's. And I can take my 4 negative 1's and I can put it with my 1. So what I've done is I haven't actually changed the expression, I've just changed the order. So now I have 3x squared take away 1x squared, plus 3 x's, take away 4 x's, minus 4 1's, adding 1 1. Now what I can do is I can simplify. Just like with integers when you learned them, you can pair up a red with another color to create 0. So negative 1 plus positive 1, that makes 0. So watch, I can put these two together, those two cancel out, and I'm left with 0. I can do the same here. I can put those together, and I can put those together, and I can put those together. And I can put those together. So what am I left with? Well, this is what I'm left with. So that means this whole expression ended up simplifying to 2x squareds minus 1x squared minus 3x's. And if we look at that, what does 3x squared take away 1x squared equal? Oops, I forgot the squared. It equals 2x squared. What does 3 take away 4 equal? It equals negative 1. What does negative 4 plus 1 equal? It equals negative 3. That is called collecting like terms. I'm now done. This, even though it looks strange, that expression is my final answer because the things that I'm left with are not considered to be like terms. So what I want you to do now is go through this rest of this on your own. So you have other questions that are in the notebook file. I want you to try these and see if you can simplify them correctly. And once you've done that, I want you to restart the video and I want you to check to see if you got the answers correct. Okay, so here is the answer to this particular expression simplified. So check to see if you got it right. If not, you can call me over and we can go over it. Here's the answer to the next one. So that whole expression simplifies to this. And then the next one, that whole expression simplifies to this. The last two, you just had to make up your own. So you had time to be creative and just make up your own. So the answers are going to vary. If you want me to check to see if you got it right, you just call me over and I can have a look.